This video will show you how to graph a quadratic function which is written in vertex form. So vertex form looks like this. Some things to remember are h and k are your vertex. So on your foldable you should have written opposite, same, because h is always the opposite sign of what you see it and k is the same sign. All right, so in your notes you have this example and we're going to go through each piece, so I'm going to zoom in here to make it easier for you to see. I'm going to start by answering, does the graph open upward or downward? And this one will open up because the a value is positive or greater than 0. Now, find the vertex of the parabola. So this is the point HK, opposite same. So opposite would be -2 and the same would be -1. Next, we're going to find the Y-intercept on your foldable. It says let x be 0. So all we're doing is substituting 0 everywhere there is an x. And we're going to do the math. So this would be 2 squared, which is 4. 4 minus 1 would be 3. Therefore, my Y-intercept is the point 0, 3. The axis of symmetry is always the vertical line, which would be x equals the x-coordinate of the vertex, x equals -2. Now, the x-intercepts are probably the most amount of work. This is again where you let the opposite letter be 0. So we're going to let 0 equal x plus 2 quantity squared minus 1. So we need to solve this quadratic equation for x. So I'm going to use the square root method rather than the zero product property or the quadratic formula since it's not written in standard form. So I'm working in reverse, so I'm going to add 1 to both sides, which gives me 1 equals x plus 2 quantity squared. Now, I need to get rid of this exponent of 2, so that means I'm going to take the square root of each side. And when I do that, the moment I do, I've got to remember that it's plus or minus. So the square root of 1 would be 1, but it's positive or -1. And the exponent and the radical undo each other, leaving you with x plus 2. So this really gives me two separate equations. One of them is 1 equals x plus 2. The other one would be -1 equals x plus 2. So I'm going to solve each of these. I'm going to subtract 2, which gives me -1 is equal to x, or subtract 2 on this one gives me -3 equals x. Therefore, my x-intercepts are two ordered pairs, -1, 0. The other one would be -3, 0. Okay, so let's graph this. Just as before, we would always start by putting our vertex in the center. Here's the vertex. And you're going to choose 2 points to the right of that vertex. I'm going to choose -1 and 0. The 2 points to the left, which would be -3 and -4, I'm going to obtain using symmetry. All right, so when I substitute in -1 into my function, I'm going to get 0, and really we already did that because that was one of our x-intercepts. However, you can verify it by doing f of 0, meaning plug in -1 into our function, do the math. You can type this entire side in your calculator. You will get 0. Then you're going to substitute in 0. And 0 plus 2, quantity squared, minus 1. We actually already did this one as well, is going to be 3. That's up above. That's your y-intercept, 0, 3. Now I'm going to use symmetry to get my others. So I know these two here have to be symmetrical. So this is 0, and this one here would be 3 because these 2 points here have to be symmetrical. All right, so I'm going to graph these ordered pairs. -2, -1 is right here, and that is my, let's see, that's my vertex, so I need my axis of symmetry, which is going to be a vertical line straight through that, and I'm going to label that as x equals negative, that should be an x, that looks like a v, say x equals -2. And I'm going to graph my other points. So I know it opens upward. Let's see. So -1, 0 is right here. -3, 0 is right here. Then I need 0, 3, and -4, 3. So there is my U. Looks like this. You're going to state your domain, and you should know that the domain is always identical for all quadratic functions. It's -infinity to +infinity in parentheses. Remember, you ask yourself how far left and how far right. The range is how low. Well, the lowest it goes would be the y value of the vertex, which is -1, and it goes infinitely upward. We have a bracket on -1 because that's included on the graph, whereas infinity you can never stop. Okay, you should be able to do some practice now graphing in vertex form.